So here are the 5.5 notes. All we're going to do for these part of the notes is add and subtract rational expressions. Okay, so remember, whenever you're adding rational expressions or subtract, you must have what we call a common denominator. So that means when you have two fractions, you need to make sure that the denominators are exactly the same. When they're exactly the same, then that allows you to add the numerators. So for example, if we have this example 1 here, you can tell that both of these fractions have a common denominator. Basically, the common denominator is 4x. Because they have that, we can add the numerators. So here we get 10 over 4x. Now, just like we did with 5.4, we need to simplify all the way. So it needs to be in simplified form. So know that we can simplify this into 5 over 2x. And that'll be our final answer for that one. For the next one, we can also see for the denominators, they are exactly the same, x plus 6. That means we can add the numerators here. So we can do 2x. Now we're doing subtractions. So we're doing 2x minus 5. Now they aren't like terms, so all we can do is do 2x minus 5 here. So we have 2x minus 5 all over x plus 6. Now, unlike the other one, this one we are not able to simplify anymore. It's in simplified form. Now notice, we can't get rid of the x's because we're doing subtraction and multiplication. Or doing addition, sorry. The only time we can actually get rid of the x's is if both the numerator and denominator, there is just multiplication there. Okay, now we've done some of these fractions when they have a common denominator, but now let's add and subtract when they do not have a common denominator. So in this case, before we do that, okay, because what we need to do is what we call a least common multiple. Now that's basically the same thing as the least common denominator, okay? You want to get basically what you have in the denominator exactly the same. Now here, all we're trying to do is find what is the least common multiple, so what they have in common here. Now, before you can do that, the first thing is we need to factor. So we need to factor 4x squared minus 16. So what we're going to do is do the greatest common factor. They both have a 4 in common. So we're going to take that out and rewrite our expressions. We have now x squared minus 4. And remember, we need to factor all the way down. So now that x squared minus 4 changes into an x minus 2, and then into an x plus 2 here. Okay, so once we factor this, now we need to factor our other one, 6x squared minus 24x plus 24. Now notice that they all have 6 in common, so we need to factor that out. So we factor it, now we're left with x squared minus 4x plus 24. Now what we need to do is we need to factor our x squared minus 4x plus, whoops, that needs to say 4 there, not 24. So now we need to factor our minus 4x plus 4. So we have 6 times, and this should be x minus 2 times x minus 2. Or you could also say x minus 2 squared. They're basically the same when you say that there, okay? Okay, so now what we need to find after we factor is our least common multiple. Now the first thing we're going to do is talk about the numbers here. So we have a 4 and a 6. Now we need to find the multiples of both 4 and 6. Now remember, multiples mean we start at 4 and we get bigger. So we have 4, that's a multiple, 8's a multiple, we have 12, 16, 20, okay, and if you need to go a little bit more, you can. For 6, our multiples, I'm going to put it over here, we have 6, 12, 18. Now notice there is a number that the multiples of 4 and 6 have in common. It is 12. So we want to pick the multiple that 4 and 6 have in common, and it needs to be the smallest number. That's why we call it the least common multiple. So now that we dealt with our numbers, we have 12 as part of our least common multiple. Now let's deal with our factored forms. Now notice for our first one, we have 4 times x minus 2 times x plus 2. Whatever the factors forms have, they need to be part of our least common multiple. So since this one has an x plus 2, that has to be part of our least common multiple. Even though the 6 times x minus 2 squared doesn't have it, if at least one of your factored forms has it, it has to be in the least common multiple. Now let's look. So we talked about x minus 2, but also notice on our other factored form, we have x minus 2 squared. They have the same factors, but one of them has 2 of the x minus 2, one of them only has 1. When this occurs, you're going to pick the biggest or the most amount. So since the 6 times x minus 2 squared, since we have 2 of those, and that's the most amount, we are going to use that in our least common multiple. So now we have x minus 2 squared. So kind of recapping there, make sure you include everything from the factored form, so from any of the factors, in your least common multiple. If it's only in one of the factors, you still need to put it there. Now, if both of the factored forms have the same something, okay, whatever it is, but one has a bigger amount of it, you go with the bigger number. Now, once you have everything and you've included everything, you box it to indicate, hey, this is my least common multiple. Okay, now let's use that information to now add our rational expressions. So here we have 7 divided by 9x squared plus x divided by 3x squared plus 3x. Now the first thing we need to do, so this is number 1, we're taking this step by step, is we need to factor the denominators. Only the denominators, okay? Because later on we'll deal with the numerators. So factor den, and den means denominator here. So we have 9x squared. Now remember, whenever you just have one term, you can't really factor it. I mean, you can maybe take things apart, but 9x squared, that's as factored as we can get. However, 3x squared plus 3x, that you can factor just a tiny bit more here. They both have a 3 and an x in common, so I'm going to take that out. So I take a 3x and rewrite my expression as x plus 1. Now, our second part of this, now that we factored the denominator, the second part is to find the common denominator. So you either can say LCM or LCD. It means the same thing. So least common multiple or least common denominator. Now let's talk about the numbers. So we have a 9 and we have a 3. Remember, we need to pick the number that 9 and 3 have in common, and it has to be a multiple. Well, that multiple should be 9. Okay? So 9 can go into 9, as well as 3 can go into 9. Now, let's see what else we can add to our least common multiple. Now, notice our 9x squared, it has an x squared. On our other factor form, we just have an x. Well, since both of them have x's, remember, we have to go with the most amount. On the 9x squared, there's 2 of the x's. On the 3x, there's only 1. So we go with the bigger amount, which is our x squared. So that is part of our LCM, our least common multiple. Lastly, we can see that the 3x times x plus 1, it has this extra x plus 1. Even though the 9x squared doesn't have it, we still need to include it into our least common multiple. As long as one of the denominators has it, then we need to include it in our least common multiple. Okay, so now what we're going to do is we need to make sure that our denominators here in our original problem have the least common multiple. So that's what we're trying to get here. So I'm going to rewrite, so that's kind of step 3, rewriting your expression here, your addition expression. Okay, so I'm rewriting it as, and I'll put this as a step 3. There we go. I'm going to write it as 7 over 9x squared plus x over. Now, instead of writing the denominator as 3x squared plus 3x, I'm going to rewrite it in the factored form because I need to know what I need to multiply that fraction by to get my least common multiple. So I'm going to rewrite my 3x squared plus 3x as the 3x times x plus 1. Now that I've rewritten it, I need to multiply my numerator and my denominator to get my least common multiple. So we look here, we only have just the 9x squared in our denominator in our first fraction. Remember, our least common multiple is 9x squared times x plus 1. So now we need to include x plus 1 in our denominator. But when you multiply the denominator by something, you also need to multiply the numerator by the exact same thing. It's kind of like saying what you do to the bottom, you have to do to the top. Okay? Or what you do to one side, you got to do to the other. So here we're going to have 7 times x plus 1. And in the denominator, we're going to have 9x squared times x plus 1. It is really just our least common multiple here. Now I'm going to do basically the same thing with my second fraction. I have to see what I'm missing from my least common multiple. Well, we already have the x plus 1, so we don't need that. But notice we have a 3 and not a 9. So we have to think 3 times what gives us 9? Well, that should be 3. So I'm going to multiply not only my denominator, but my numerator as well by 3. And also notice here that we only have one x, not 2. So I also need to multiply the top and the bottom by an x. So total, I am multiplying my numerator and my denominator by 3x. Now on the bottom, I just already basically multiplied it by 3x to get it the same. Now what I need to do is kind of go ahead and distribute my 7 in the numerator, multiply the 3x and x. So kind of just make it a little more aesthetically pretty here. So I have 7x plus 7. So all I did was distribute the 7 to both the x and the 1. And that's still over my least common multiple, 9x squared times x plus 1. Then I added to my x times 3x, which gives me 3x squared, all over my 9x squared times x plus 1. Now that I got my denominators to be exactly the same, I just combine my numerators. So 7x, there's no common things that I can add it with. 7 I can't add that with, and 3x squared. So now what I'm going to do is just write my quadratic in ascending order. So now, setting it equal to, solving here, I have 3x squared plus 7x plus 7. And that's all going to be over my common denominator of 9x squared times x plus 1. Now, after this step, usually you would factor the numerator and see if you can cancel anything from the numerator and denominator. I'm going to already tell you now, hey, you can't actually factor the numerator. So in this case, because we can't do that, we are already in simplified form. So this would be our final answer here. Now make sure if I'm going too fast, you pause the video or slow it down. Okay? And sometimes you might have to go back to look at things. Okay, now let's apply this information to when we subtract fractions. So we're going to use the same process here. So we are going to subtract x plus 2 over 2x minus 2 minus negative 2x minus 1 all over x squared minus 4x plus 3. Okay, using my steps. The first step, remember, we are going to factor the denominator. Now, I would suggest you try to factor the denominator as well as find the least common multiple on your own, just to check that you understand this information, okay? So at this moment, I would like you to go ahead and pause the video, factor the denominator, so that would be your first task. After you factor the numerator, then you would go ahead and find your LCM, the least common multiple. Okay, hopefully you paused the video, you tried to factor the denominators, and then find the least common multiple. If not, okay, let's go over how you do this. Okay, so we have, once again, two parts to our denominator. We have 2x minus 2. I'm going to keep this color-coded here. So we have 2x minus 2. And then on the other one, we have x squared minus 4x plus 3. Okay, now 2x minus 2, they should have a 2 in common, so we're going to take that out. So we take a 2, and then we're left with x minus 1. And on the other one, this one you actually have to factor. So this should be factoring out x. We should have minus 3, and then also x minus 1. Now, using our factored forms of our denominators, we are going to figure out the least common multiple. So I'm going to scroll this down. There we go, so I can write there. Okay, least common multiple. Now, notice we have a 2. Now, you might not see it, but there's an assumed 1 right here. So you need to write that in so you know to figure out the number for the least common multiple. That might be a good idea. Now, the multiple that 2 and 1 have in common is the number 2. So remember, you write out the multiples. So we add 2. Now, if we look here, the 2 times x minus 1, it has an x minus 1. And for our other factored form, we also have an x minus 1. Now, two of the denominators have the same factors and the same amount of them. We just write it that amount. Since there's only one x minus 1 on our second denominator and only 1 in our first denominator, we just write it once. Because remember, the biggest amount of times we see x minus 1 and each denominator is just 1 time. Now we write whatever is left. So I think we're done with the 2 times x minus 1. We've kind of exhausted our options there. But notice here we have an x minus 3. So we also need to include that in our least common multiple. Remember, if the denominators have something, you need to put that in the least common multiple. So you cannot forget that. Okay, so now that we found our least common multiple, we now need to rearrange our fraction so that it has our common denominator. Okay, I'm going to scroll up just a little bit here. Okay, so doing part 3, what I'm going to do is rewrite my fractions so that my denominators are in the factored form. So I have x plus 2 all over, 2 times x minus 1. So just rewriting my denominators in factored form. Don't forget this is a minus and then a negative 2x minus 1. All over, factoring my denominator here, which we've already done, x minus 3. And then times x minus 1. Now what we're going to do is we're going to multiply so we know what our least common multiple needs to be in the denominator. So this is our part 4. Okay. Now if we look at our first fraction here, okay, and comparing it to our least common multiple, it has a 2 and it has an x minus 1. But what it's missing is the x minus 3. So I need to multiply by the top and the bottom by an x minus 3. So remember, what you do to the top, you got to do to the bottom, and vice versa. So now I have a common denominator. It is going to be 2 times x minus 1 times x minus 3 minus, now notice for our denominator here we have x minus 3, okay, that checks off, x minus 1, well we're missing a 2 here. So we will have to multiply by a 2 for our top and our bottom. So we times 2 times our negative 2x minus 1. And in the bottom we should have the denominator of 2 times x minus 1 times x minus 3. Now what I'm going to do is I'm going to FOIL my x minus 3 and x plus 2. And scroll down here. So when I do that, I should get x squared minus an x minus 6 And still in the denominator, I have my least common multiple, so 2 times x minus 1. And then x minus 3. And then minus, now I distribute my 2 to the negative 2 and to the negative 1. So now I have negative 4x minus 2 all over my denominator. Now notice in this case we are subtracting. When you are subtracting, I would advise changing the subtraction into an addition, and then changing your second fraction and changing those signs. So what I mean is changing this into a plus, and then for each term behind the minus, changing the sign. So changing a negative into a positive and changing our negative 2 into a positive. That will allow you to probably make it easier for yourself to subtract and not forget to really distribute that negative. Okay, so now I'm going to combine like terms. X squared is all by itself, so I just have x squared. Now negative x plus a 4x, that should give me plus 3x. Then negative 6 plus 2, that should give me minus 4. And then my denominator here. Now, unlike the other one, we could not factor the numerator, so we were kind of done with the problem. But if it's possible, the very last step is to simplify if necessary. That means you might have to factor basically the numerator here. There we go, get it up there. Okay, let me do my last color. So this will be number 5 here. So simplify. So we're going to go ahead and factor the numerator. This should be factored out to be x plus 4 and x minus 1. And then we have our denominator, our least common multiple here, 2x minus 1, and then x minus 3. Now if you notice, we both have an x minus 1 in the numerator and denominator. Those cancel out. Now that we can't cancel anything out, we still have an x plus 4 in the numerator. And then lastly, we just have the 2 times the x minus 3 in the denominator. And because we can't simplify anymore, this will be your final answer. Okay, I would advise you trying 2 through 30 even in the homework, so you can make sure that you know how to find the least common multiple and you kind of know how to add and subtract rational expressions. So this is page 340, and just try 2 through 30 even. And then if you have any questions, make sure you email me or come in before or after school to get some help.